All right, happy snow day, everybody. We're going to be doing section 1F by video today. I'm going to split this up into a few different videos. Let's see, so this first one we're going to talk kind of about a review of graphing and slope of lines. Okay, so I'm going to talk about graphing by plotting points. So anytime, no matter what math class you're in, no matter what equation you run across, if you don't know what the graph looks like, you can always try plotting points. It works for any kind of equation. All right, so we're going to pick a really simple one. Y equals 2x plus 1. All right, and I'm going to see if I can figure out what the equation of this line, what its graph looks like by plotting some points. So I'm going to make an x and y table. I'm just going to pick some values for x. All right, some negative ones and some positive ones. We're just going to see what the y coordinates are equal to. All right, so I'm just going to go up to my equation. I just randomly picked this equation. Okay. 2x plus 1, and everywhere there's an x, there's just one x in there. Wherever that x is, I'm going to replace it with my values of x that I picked. Okay, so I'm going to pick x equals negative 2. When I plug that in, I'm just plugging that equation, 2x plus 1, 2 times negative 2 plus 1, and figure out what the y coordinate is. So negative 4 plus 1 gives me negative 3. Okay, so just, I'm going to keep going down the list and plugging in those x coordinates. So I'm following the same pattern, filling in this equation. Wherever there's an x, I'm replacing it with the x value in the table. And then we just do the arithmetic down the right-hand side. Okay, so when I plug in negative 1 up here, I get 2 times negative 1 is negative 2, plus 1 is negative 1. 0 plus 1, 2 plus 1, 4 plus 1. Okay. And what this table is doing, it's giving me a bunch of y coordinates for every x coordinate. So when I plugged in negative 2, I got negative 3. That means the point negative 2, negative 3 is on the graph of my equation. So I'm just going to go down and make these all into points. These are points that we're going to plot on the graph. Okay, so I'm going to go over to my graph and I'm going to plot these points. So I'm going to go x equals negative 2, y equals negative 3. Okay, so there's my point, 2, negative 3. Sorry, negative 2, negative 3, negative 1, negative 1, 0, comma 1, 1, comma 3, and 2, comma 5. Okay, so it looks like all of these points that I plotted lay in exactly a straight line, and that is the case for this one. All right, so it turns out that to graph a line, you only need 2 points, so 5 was overkill. But if you didn't know that that was the equation of a line, you didn't know how many points you needed to plot. All right, so whenever you plot points, you kind of connect the dots. You want to go beyond the points that you plotted because we want to imply that I could have, put arrows on the end, I could have continued to plot points. I could have plot negative 3, I could have plot 7, I could have plot any point that I wanted. And I would still have found it lying on this straight line. Okay, so that's our graph. All right. All right, so in general, if you have an equation, y equals mx plus b, okay, and we had y equals 2x plus 1, you can predict just by looking at that equation that its graph is going to be a line without plotting points. All right. And so the m and the b are always just numbers. So in our case, m was equal to 2 and b was equal to 1. All right, and we give those numbers names. That number m is called the slope. All right, and we're going to beat slope to death in the next couple of slides. And that 1 tells you about the Y-intercept. All right. Okay, so when I graphed that line, we got something that looked like this. All right, and so that spot where I crossed the y-axis, that was the point 0, 1. We plotted that point 0, 1. Okay, we can tell just by looking at the equation of a line, if we recognize it's going to be a line, we can tell by looking at that value of b what the y-intercept is going to be. So we'll know exactly where that is. And then once we know that, we can use the slope to figure out what the line looks like. All right, so let's talk about that slope. The slope of a line, that's that number m, y equals mx plus b, is a numerical measure of how steep it is. All right, so we are going to want to come up with a numerical way to measure, to measure how steep a line is. So if I have a line with kind of a gentle slope versus a line with a really steep slope, okay, the slope is going to predict how steep that line is just by looking at the number. Okay, so let's think about the steepness of a line. All right, so I'm going to plot 2 points here. I'm going to plot a point over here and a point up here. All right, and I'm going to call this first point over here x1, y1, and this one up here x2, y2. Okay, so I'm calling both of them x comma y, but I'm giving them little subscripts to say that they're 2 different points, the first point and the second point. Okay, so let's kind of connect those 2 points with a line. All right, and we want to talk about how steep this line is. Okay, so steepness, sometimes we think of slope and steepness as rise over run. You may have heard that before. Okay, rise being how much you go vertically and run being how much you go horizontally. So for our line, if I'm going left to right, how I travel from one point to another, this distance right here is what we call the run, how far I have to go to the right or to the left. And this is going to be my rise. Okay, so we'll draw a little right triangle there. So this is the run, and this is the rise. Okay, so if you have to rise a whole lot, that's going to give you a bigger number for your rise over run. If you're not rising very much on a line with a gentle slope, that rise is going to be kind of small, so you're going to get a small slope. Okay, so this ratio of rise over run is going to tell you how steep a line is. Okay. So again, let's think about those coordinates, the x1, y1. So if this is the point x1, y1 over here on the left, that means this is the x1 coordinate on the x-axis, and this is the coordinate x2 on the x-axis. Okay, so that run, the run labeled on that triangle is just the distance between those two x coordinates. Okay, likewise, if I think about in terms of rise, my y coordinates, this is y1, and up here is y2. Okay, those are the y coordinates. That rise, if you think of the y-axis as a ruler, okay, the rise is just the distance between those two tick marks. Okay, so if I want to figure out the distance on the x-axis between two coordinates, I can just subtract them. Okay, think if this was going from x equals 2 to x equals 5, that'd be a distance of 3. We're just subtracting the bigger number minus the smaller number. Likewise, on the y-axis, bigger number minus smaller number. Okay, so if I want to find the slope of a line, the rise over run, we're going to do the rise, the y coordinates on top, you're going to subtract y coordinates. The run, you're going to subtract x coordinates. Okay, so that's your rise over run. So rise over run is how we're going to think about slope practically. This is going to be our formula for actually calculating the number of the slope of a line. Okay, so I'm going to take that formula onto our next slide. Okay, and we're going to find some slopes of lines. Okay, so the first one, I'm going to give you 2 points. -1, -5, and 2, 1. Okay, so I'm going to write our formula for slope. Again, always copy down this formula every time you do it, just like with our quadratic formula from last time, and by the time you're done with your homework, you're going to have the formula memorized. All right, So it doesn't matter which point you call x1, y1, and which point you call x2, y2. All right, it does not matter. I'm going to label the first point, this kind of makes sense to call this x1, y1, and this one x2, y2. All right, but it doesn't matter, just as long as you put the same subscript in the same point. Okay, so you can't say x1, y2 or something like that. All right, so I'm just going to plug those numbers in. Y2 minus y1, that means I'm going to be subtracting right minus left. All right, so always the y coordinates on top. Y2 is 1 minus y1 over x2 minus x1. Okay, so I did right minus left. And then just simplify, that's just some arithmetic. On top, I get 1 plus 5 is 6. On bottom, 2 plus 1 is 3. There's some easy arithmetic. 6 divided by 3 is 2. Okay, so this line has a slope of 2. Okay, and I want to think about what that slope 2 means. So let's plot these 2 points, -1, -5, and 2, 1, over here on the right. Okay. Did I mention this stylus is super easy to use? Just kidding. It's sort of awful. Okay, so -1, -5, -1, 1, 2, 3, 4, 5. So I'm going to plot a point down there. And then I'm going to plot 2, 1. 1, 2, 1. All right, and then I'm going to connect the dots between those 2 lines. Do what I can here. Okay, so there's my line. Okay, so that rise over run that we calculated, okay, we got 6 over 3 before we reduced. Okay, and again, that is, we're going to draw this triangle. That 6 was our rise. That was our vertical distance to get from one point to the other. We had to go left to right. We had to go up 6 units, and we had to go right 3 units. Okay, but that 2 ratio, so if I think about that slope as 2 over 1, that ratio works for any 2 points on this line. You can kind of see, if I think about, looks like it crosses the y-axis here at -3, and it also looks like it goes through 1, -1. Okay, that same ratio is going to work for any 2 points on this line. Okay, here it's not 6 over 3. This is a rise of 2 and a run of 1. Okay, but that 2, 1 works even if I go from this point at 1, -1 up to 2, 1. Okay, a rise of 2, a run of 1. Okay. All right, so that's a constant throughout this whole line. Okay, so sometimes it's bigger, sometimes it's smaller, those ratios, but always the ratio is equal to 2 for this line. Okay, so let's do another one. Okay, so you might want to pause the video and see if you get the same answer that I do, just to see if you're getting the idea here. Okay, so this time we're going to do the point -2, 2, and 4, -1. All right, so again, I'm going to write down my formula for slope. Okay, and you may pick, does not matter which point you label as x1, y1, and x2, y2. Just keep the same subscript in the same point. All right, so I'm going to subtract y2 minus y1, so that's -1 minus 2, and 4 minus -2. All right, the rest is just arithmetic. -1 minus 2 is -3. 4 minus -2, that's 4 plus 2 is 6. All right, so those are the same numbers as last time, but they're in the different spot. Okay, so the smaller number's on top. So when I reduce that, 3 goes into 6 2 times. Okay, so that's going to reduce to -1/2, and that's our slope for this line. Okay, so that's a smaller number. Last time it was 2, this time it's a half. Okay, so we expect this to have a gentler slope to it because it's got a smaller slope. Okay, but let's plot those points and see about that ratio, that -1 to 2, and maybe figure out what that negative means. Okay, so I need the point -2, 2. -2, comma 2. And then we want the point 4, -1. 1, 2, 3, 4, -1. All right, so there's my line. I'm just going to connect the dots. All right. All right, so we did rise over run. Okay, so I'm going to kind of draw my little, my little triangle down here. Okay. So you can kind of see the negative as it shows up when I draw this triangle. I still went to the right a positive amount, but in order to stay on this line, I had to go down. That's why we had ended up with a negative number. Okay, so this line is falling left to right. If you kind of go back to the last example, it was rising left to right. Okay, so that's why we ended up with a negative slope on this one, because we had to rise a negative amount. We're falling left to right. Okay, so we get this slope that is -1/2. And again, if you kind of zoom in to any 2 points, okay, so it kind of looks like it goes through that point, the X and Y intercepts there. Okay, so I'll draw the triangle on top, doesn't matter where it is. Okay, so if we think about, we went to the right 2 units and we had to go down 1 unit. Okay, so that rise over run, Y over X, gives you that -1/2. So that number is a constant for this line. All right. And okay, so let's do 2 more. Again, if you want to kind of pause it and see if you get the same number that I do, or mute it. Okay, so our third pair of points is 3, 6 and 1, 6. Okay, so our slope formula, as always, write down the formula. Okay, so y2 minus y1, right minus left, x2 minus x1. Okay, again, you can do left minus right as long as you do the same order on top and on bottom. You'll get the same answer as I am. Okay, so on top, 6 minus 6 is 0. 1 minus 3 is -2. Okay, and 0 divided by anything is 0, so our slope is 0. Okay, so that slope is neither positive nor negative. Okay, so let's see, and the reason why it was 0 is because the 2 points had the same y coordinate. So what does that look like graphically whenever you have the same y coordinate? Okay, so I'm going to plot these 2 points. Okay, I had 3, 6. I'm going to plot that point. And 1, 6. Actually, I already have that all labeled there. 1, 6. All right, so there's our line. You can see that having the same y coordinate actually caused this to be a horizontal line. And it makes sense that the slope is 0, because no matter how far I run left to right, my rise is always 0. Okay, so your rise over run, okay, this line is all run and no rise. Okay, so you get a slope of 0. All right, so one more. Finding slope. Okay, so part D. We're going to look at the points 1, -5, and 1, 2. All right, so my slope formula, y2 minus y1 over x2 minus x1. Okay, subtract y coordinates. Let's see, right minus left. y2 minus y1, x2 minus x1. Okay, so subtract y. Y is always on top, x is always on bottom. Let's see, this ends up being 2 plus 5 on top and 0 on bottom. Okay, so this also gave us a 0 in the slope calculation, but in a different spot. And remember that you cannot divide by 0. That is undefined. That does not exist. So you can either say that this slope is undefined, or you can say that it does not exist. Okay, M equals undefined is kind of a weird thing to say. Let's say M is undefined. All right, and then again, let's graph these 2 points and see what that looks like to have a slope that is undefined. What does that even mean? It sounds like a weird thing. Okay, so I need the point 1, -5. 1, 2, 3, 4, 5. We'll go plot that point. And then the point 1, 2. 1, 2. All right, so this point, this line had, so this point had the same x coordinates. These 2 points have the same x coordinate, which ends up giving us this vertical line. Okay. Let's try that again. All right, that's a little better. Okay, so there's our vertical line. Okay, so you can see that this line is all rise and no run. Okay, so it doesn't matter how much you rise, you're never going to run. Okay, so if you think about slope, this line is sort of infinitely steep, right? If you think about climbing a mountain, we wouldn't want to climb this mountain. It's infinitely steep. Okay, all rise and no run. Okay, and we can't divide by 0, so we say that that slope is undefined. All right. Okay, so in general, what did we learn about slope? We found that if the slope was positive, okay, then we had a line that rose left to right, okay? Both rise and run were positive. The line will rise left to right. We found that if m is negative, that was going to fall left to right. If m is 0, okay, that was the line that was no rise and all run. You got a horizontal line out of that. And then if m is undefined, we had a vertical line. All right. Okay. So that's our summary of slope. So I'm going to stop this video here. We're going to pick up with the next video on how to find the equation of a line, given some information about the line. And we'll kind of pick up with what we have from this video on slope.